We have hit a wall. For the last 3 years, the entire world has been obsessed with the models. We talk about GPT-5, Gemini, Cloud, and Llama. We talk about parameters, we talk about reasoning capabilities, and the context windows. But while we were arguing about which model is smarter, the engineers building the hardware were quite in panic. You see, artificial intelligence has a physical limit. It's not the code, it's not the data, it's the energy. I'm Neeraj, and welcome to the very first episode of the brand new series, What's the Buzz? Training a single frontier model today consumes as much electricity as a small country. By 2030, estimates suggest AI could consume 20% of the world's total electricity supply. We are running out of the power grid to plug these things into, and we are running out of water to cool them down. Google looked at this problem, this existential threat for the growth of AI, and they asked a question that sounds completely insane. Why are we keeping these computers on Earth? Welcome to Project Suncatcher, Google's official moonshot to build world's first orbital AI data center. This isn't a science fiction. It's announced this month in November 2025. It is real, it is funded, and the prototypes are launching in less than 2 years. Today we are going to break down exactly how Google plans to put a supercomputer in space, why it is the only way to save the AI from stalling, and the terrifying engineering hurdles they have to solve to make this work. To understand the Suncatcher, you have to understand the physics of desperation. Right now, the terrestrial data center, the one hosting this video you're watching, is fighting two main enemies: intermittency and heat. Solar power on Earth is great, but sun goes down every night. Wind is great until it stops blowing. This means the data centers needs massive batteries or fossil fuel backups to run 24/7. But in space, specifically in a sun-synchronous orbit or dawn-dusk orbit, the sun never sets. Google's research shows that a solar panel in this specific orbit can generate 8 times more energy than the same panel on Earth. It is continuous, clean, unfiltered fusion energy directly from the source. No cloud, no night, no atmosphere blocking the rays. But there's a second reason it's even more critical: cooling. On Earth, keeping the AI chips cool requires billions of gallons of fresh water. It's an environmental nightmare. In space, the ambient temperature is effectively absolute zero. Now, cooling in a vacuum is actually tricky. We'll get to that point in a minute. But the potential to dump heat into infinite void without using a single drop of water is the holy grail of sustainable computing. So the theory is perfect: infinite power, infinite cooling, zero land usage. But how do we actually build this? This is where the engineering gets wild. Google isn't building a giant monolithic international space station. That's too risky. If one thing breaks, the whole data center dies. Instead, Project Suncatcher is a constellation. Imagine hundreds of small modular satellites flying in a tight formation. Each satellite is a node. Inside each node is a TPU, Google's Tensor Processing Unit. Specifically, they are testing the Trillium V6C chips. These aren't your standard laptop chips. They are AI accelerators designed to handle massive matrix math required for deep learning. Now, usually, radiation in space destroys electronics. It flips bits, crashes systems, and fries circuit. But Google have already run radiation tests on these TPUs, and result claims that they survive 5-year mission in low Earth orbit without permanent failure. But here is the killer app: free space optical links. If you have 100 satellites, they need to talk to each other instantly to act like one big brain. You can't use wires, you can't use standard radio, it's too slow. So Google is using lasers. They are aiming for data transfer speeds of terabits per second between the satellites. So this is faster than the fiber optic cable coming into your house. This laser mesh allows the constellation to train one massive AI model distributed across hundreds of miles of empty space. and they are moving fast. Google has partnered with Planet, the satellite imaging company, to launch their first prototype by early 2027. That will be the proof of concept. They are going to put the TPUs up in the space and shoot lasers at each other and see if they can actually run the neural network in zero gravity. Now take a breath. Because if you're an engineer, you probably may be screaming at your screen. It's not that simple. And you're right. There are three massive problems that could turn Project Suncatcher from dream to disaster. Remember how I said space is cold? It is. But space is also a vacuum. A vacuum is a perfect insulator. And that's why your coffee stays hot in thermos. On Earth, we use air to blow heat away. In space, there is no air. You can only get rid of heat through radiation, literally glowing the heat away as infrared light. And this is incredibly inefficient. Google satellite will need massive, heavy radiators just to keep the TPUs from melting themselves. And if they can't solve the heat rejection physics, the chips will throttle and the whole system becomes useless. Problem 2. Latency. So light is fast, but space is far. If you're using ChatGPT, you want an instant answer. Sending that request to space, processing it, and sending it back adds latency. So this means Suncatcher probably won't power your chatbot. Instead, it is likely to be used for training, the month-long process of teaching a model. And that doesn't need to be instant. It just needs to be fast and powerful. But it effectively splits AI into Earth AI for users and space AI for training. Problem 3. The space junk. This is big one. Critics are calling this nightmarish swarm. We already have thousands of Starlink satellites, and now Google wants to add thousands of data center nodes. If one of these hits a piece of debris, it shatters into thousands of bullets and can destroy other satellites. And unlike a server on Earth, if a RAM stick fails in space, you can't send a guy named Dave to swap it out. It's dead weight forever. And we are risking turning low Earth orbit into a graveyard of obsolete processors. So is the Project Suncatcher a stunt, or is it the future? The answer depends in one another company, SpaceX. Google's internal math says that this becomes profitable only if the launch cost drops below $200 per kg. Right now, we aren't there. But if Starship succeeds, and if we get truly reusable heavy lift rockets, then the cost of putting the data center in orbit is comparable to building one in California. Sundar Pichai called this a crazy example of long-term thinking. But look at the trend line. We are building digital gods that eat electricity. We cannot keep burning coal and draining rivers to feed them. We have two choices. We either stop building AI or we leave the planet. Project Suncatcher is the first serious declaration that the future of intelligence is not terrestrial, it's orbital. Coding wars were just the beginning. The space data war have officially begun. What do you think? Is this solution to our energy crisis, or are we polluting the space with our digital trash? Let me know in the comments below. And if you want to keep up with the tech that's literally leaving the atmosphere, please subscribe to Decode AI. Thank you.